Mathies, we are looking at line of best fit today, interpolation, extrapolation, all that good stuff. Line of best fit is a trend line, and it runs through a scatter plot. And the problem with that is it could be the line could look like that, the line could look like that, the line could look like a lot of different things. So there are some general guidelines that we use to make the line of best fit. One of which is that it needs to go through the mean point. And the mean point isn't like the meanest one. It's you average all the x's. You add up all the x's and divide by the number of numbers. And so you'd add 10 and 11 and 12 and 13 and 13 and 15 and 16 and 16, etc. You divide by whatever, 20 points, 10 points, and you'd get an average. My guess is it would be here. The average would be about 15. And you'd do the same thing for the y's. You'd add up 15 and 18 and 20 and 20 and 27 and 22 and 23, right? You do that and average that, and you get an average value for the y. And that's the average x and y, and that's the one you draw your line of best fit needs to go through that line, or to go through that point. And then it should also cut the data approximately in half above and below the line. So you get half the data points above and half below, roughly. That's generally how to do it, right? And so that's not bad, right? So that's mine. It's open. It's a little bit subjective. It's open to some error, and so we also want to be able to do that with tech. I'll show you that in a second. So here are some trend lines that kind of roughly match the data, and we want to be able to do that legitimately with your calculator. So bust that thing out. This data is the weight of a person and their maximum speed. And I want to be able to get an equation and graph it. If you go into statistics and hit enter, I took the liberty of putting 85, all of this top line in L1 and all of the bottom line in L2. So this is the weight of the person, the mass of the person, and the maximum speed. And I want to build an equation for that. One thing you can do is go second stat plot, and you can say on, and if your points are on this dotted set, when you go to graph, no, I don't see anything here because it's not zoomed in the right spot. So you can go zoom statistics, so 9, or go down, and that'll make a nice graph. There's all my points, right? So I want to drop a line through there. That's what this cluster is. I want to zip a line through there, so I want the statistics to be calculated for me. I want it to calculate a linear regression for me. Linear means a line, regression means an equation that doesn't perfectly hit. It's just it's a line of best fit. My x's are in L1, my y's are in L2. That's fine. Go down to calculate. Oh, a neat trick is in store regression equation. You can have this calculator give you the equation, but you can also have it immediately put it into y equals. I don't use this very often, but if you go into vars, go into y vars and function and y1, this says store the regression equation in y1. Fussy little trick, but it sometimes is useful. So go down to calculate, ba-boom. This is the equation that works for my data as it is right here. So you can either write it out and then put it into y equals, or if you've done that fussy little trick, should already be in there in all of its decimal glory, right? There's the x and then the 44 point blah, blah, blah at the end. And now when we hit graph, we see the line go through, which is really nice. Okay, so we use tech to, oh, did we find an R value? Stat, 4. No R value. So I can't tell how good the graph is, the line is at approximating my data. You'll only need to do this when you turn on or off, like when you switch batteries. But if you go second memory, and, second catalog, and you go down to diagnostic on. There are other ways to do this, but this is, I think, the most straightforward. You go down to diagnostic on, and you hit enter, and you hit enter again. It says done. Now if we play that same game, calc linear regression for boom, 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 boom. It gives us A and B, but it also gives us this R value. It's negative because it's going downhill. The more you weigh, the slower you can run, apparently. And 0.81 means it's pretty strong, right? The R squared we use for other things. It's literally this number squared, but we use it for other statistical assessments. That's all fine and good. It's still this line. So now let's use our regression to find the speed of a 72 kilogram person. I'm 72 kilos, so let's say it's how fast I should be able to run. If you say second calc, we can calc for a certain value. What X value? Well, 72. And it says 25.6. 72 would be kind of around this person. Is this seem to work with our data? Yeah, sure. 20, 24, 25. All right. What about a 12 kilogram person? Let's try that. So I'm just going to type in 12 and see what happens. Oh, it says error because my window isn't big enough. So let's go to window, and I'm going to back it up. My X minimum I want to be 0, a 0 kilogram person, and my Y maximum, let's do, I don't know, just throw something weird in there and see what happens. Okay, so there's my data. It's kind of crunched over to the side. So now if I put second calculate, I want to calculate the speed, the Y value, when I have a 12 kilogram person. My daughter is 3 and she's about 12 kilograms. Holy smokes, she can run 41 meters per second, kilometers per hour, 41 kilometers per hour, right? And I can only run 26 according to my data. So my equation works, but I'm interpolating for my value and extrapolating for hers. Let me explain that part to you. Hopefully you can, the calculator part you should be able to do with no problem, but interpolating and extrapolating are two different things. I like this. They just got married and he says, hey, today you have one husband and yesterday you had no husbands, so statistically if you extrapolate, you should have a lot more in a week. Interpolating means you're looking at the trend within the data that you have, the data that you know exists. So this is interpolation, and that's good, statistically good. We like interpolation. Extrapolation is continuing that trend outside of your data, and that is statistical death, right? Because you don't know that it's going to work. So like my data here, my 72 kilos was within here. Whoa, can't see. My 72 kilos was within this. If you push 72, 72 is right there, and it's within my data set. That's interpolation, and we can be confident of that value. But my 12 kilogram daughter is way outside our data set. That's extrapolating, and we can't tell that we can't say for certain that the trend will hold up. So that's outside, that's extrapolation, that's bad, statistical death. For example, here's the health effect on the dose of medication. Maybe this is like, I don't know, how your temperature changes if you have a fever, or based on that, or maybe like how happy you are versus how much vitamin C you're taking. And I see this increasing trend. So any amount that if I have a trend here and I pick something in the middle and I see how much the dose affects the health change, that's fine. Once I start extrapolating beyond that dosage, that's not good because I don't actually know what's going to happen. Right? I can't, because I didn't know this is going to behave like this. I'm flying blind, right? So interpolation good, extrapolation bad. Cool. Try that out, and I'll see you later.